friends, welcome back to our Associates. Today we will calculate wind load, but before that we have to assign diaphragm in our structure. Basically, which comes from earthquake calculation. So you can see that for our structure time period is 0.74 second. So if we need to calculate the frequency of our structure, we have to take 1 divided by t. That means 1 divided by 0.74, which is equals to 1.35 Hertz. If the frequency of our structure is greater than 1, in that case we have to consider the structure as rigid structure. Hence we have to assign rigid diaphragm. If the frequency of our structure is less than 1 Hertz, in that case our structure will be flexible structure or semi-rigid diaphragm has to be assigned. Okay, in this case our structure is rigid structure. So let's go to define diaphragm. Here you can see that by default this diaphragm is rigid. So okay. Now go to story 1, go to select coordinate specification, click joint in XY plane. There have two procedure of assigning diaphragm, but I think this is the best procedure. If you follow this procedure you will not get any diaphragm warning. So let's assign shell diaphragm, select D1 and apply. Go to next story. This is a reference plan, so we don't need to assign diaphragm there. Again go to select coordinate specification. Okay, apply. Next, apply. Next, apply. 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 Okay. Now if we analyze the structure, we will see that we didn't provide any meshing in our structure, so this is showing this type of condition, but if we assign mesh, this will show us more accurate result. Okay, let's uncheck this one and provide meshing. Go to select object type, floors, walls, select close, assign shell, floor auto mesh, auto cookie cut, further mesh 12 inch, and here from advanced select 1 feet, that means 12 feet. Okay, apply. Okay, previous selection, assign shell, this time wall auto mesh, auto rectangular mesh, advanced 1 feet. Okay, now if we analyze the structure, say after assigning mesh, load distribution is more accurate. That's why we assign mesh manually in ETABS. Okay, fine. Now if we go to analyze, display, show table, analysis, result, structure result, you can see that ETABS not showing us these two values. Okay, but we need these two values for calculating eccentricity ratio of this building. So what we have to do, we have to uncheck the structure or unlock the structure and go to analyze, set load case to run. From here select calculate diaphragm center of rigidity. Okay, now run analysis. We will use a Excel sheet for calculating eccentricity ratio. Also I will show you the reference. Okay, now go to ETABS. This time if we go to display, show table, structure result, center of mass and rigidity, you can see that ETABS has calculated these two values. Okay, we need these values in SI unit, so select metric SI. We can ignore that window. Now from here select ascending and copy all the data. Okay, we are doing all these things for calculating wind load basically. Okay, now go to the Excel and paste these values. Okay, we need the value of Bx and By. Which one is Bx and which one is By? Let's go to bnbc 220. Here in page 3155 of bnbc or pdf 577, you can see that these are the, this one is Bx and this one is By. That means we have to consider Bx in y direction and we have to consider By in x direction. Okay, and the maximum eccentricity ratio will be 0.15. In my previous video in my channel, I have discussed this broadly. Okay, I will not waste time here anymore. So the main thing is Ex divided by Bx equals 0.15. This is the maximum allowable value. If the value is less than 0.15, then it is more okay, but the maximum acceptable value is 0.15. Okay, fine. So the main thing is which one is Bx. The value in y direction is Bx and the value in x direction is By. Okay, fine. For our structure, the dimension of y direction is 52.4 inch. If we convert these values in meter, we get 15.97. That means Bx value equal to 15.97. Okay, and the By value is 37 feet 2 inch. That means 37.17 divided by 3.28 equals 11.33. Now if we drag these values up to here and these values up to here, we can see that maximum, here the maximum value is 0.13. that means okay for x direction or Ex by Bx ratio, and this is for Ey by By ratio. That means for our structure there is no issue of eccentricity failure. Okay, fine. Now, which value we should consider in ETABS? For EX or E1, we can consider here the maximum value equals 0.137. That means we can take 0.14. Please note down E1 equal to 0.14. The maximum value in this column. And for UI by BY ratio, the maximum value is 0.058. That means we can take 0.06. That means we can take 0.06. This is the maximum value in this column. Okay, fine. Let's unlock the structure and go to this Excel sheet now. Okay, here I have collected this sheet from online. Here you have to select wind parallel, wind speed as per the location of our structure, which we can get from ETABS. For calculating these things, we have to select this one. I have prepared this one. Here we need to go page 603 of my bnbc. So from here I am selecting 603. This building is in Dhaka, and for Dhaka the wind speed is 65.7, where unit is meter per second. But if we need to convert this in mile per hour, we have to multiply this value by 2.24. So let's go to Excel. Here 65.7 multiply with 2.24. okay, here our building classification was 1. Exposure category we will take B. You can find this in bnbc also. Check this one. We can get this from page 554. okay, 554. Basically, exposure A is for urban area, exposure B for semi-urban, and exposure C for coastal area. So you can check this from bnbc page 3132. Let's move forward. Here we are considering B. Basically our structure is in exposure A, but in ETABS which one is A we have to consider as B, which one is B we have to consider as C. Okay, fine. And which one is C we have to consider as D. Okay, fine. For our structure there is no ridge, no edge, so all two values will be same. Okay, fine. If there is any confusion about ridge and edge, you can check online. Then what is the height of our structure? The height of our structure was 71 feet. Hopefully you can remember from earthquake hand calculation. Now what is the width of our building? Okay, what is the width of our building? That means the value in y direction. Okay, and what is the length? So the width of our structure is equals to 52.4 feet. 52 feet 4 inch. That means 52.33 feet, and the length of our structure was 37 feet 2 inch. Okay, 37 feet 2 inch. That means 37.17. Here we will consider monoslope since there is no ave in our structure. Topographical factor we consider this as 1. If we need to check from bnbc, you can get this in 556. here you can see that recommended value for kzt equals 1 if your structure is in a plain area. If your structure is in a hilly area, you have to calculate this from this equation. Here we will take kzt equals 1. Okay, then we need directionality factor. You can get this from six zero six. There you can see that for building frame system which is main wind flow resisting system, the value of kd equals 0.85. so let's take 0.85. Enclosed, yes, our structure is fully enclosed. If we had a structure like this, okay, we could consider this as partially enclosed, but this is a building structure and our structure is fully enclosed. We will take here y, that means yes. Hurricane region, we can take this yes. Okay, maximum value of eta equals beta equals 0.15. hopefully you can remember the recommended value in bnbc for beta equals 0.15. okay, then here comes ct, the value of ct, which is 0.0466. basically these all values are coming from earthquake hand calculation. Here you can see that the value of ct, yet the value of ct equal to 0.0466. okay, 0.0466. after changing all these values, we have to make a correction here, which is time period t, because in our structure the time period was 0.74. okay, just put these values here, and from here we can get all other values. Now go to ETABS and go to define, go to load pattern. Here define wind x, take wind. Here code will be ASC 705. add new load wind y, ASC 705. now go to wind x, modify lateral load, keep this same, go to user define. Here windward coefficient and leeward coefficient, which we can get from the Excel sheet. Here windward coefficient is 0.80. this is always constant for calculating wind load, but the value of leeward wall will be changed according to the value you provide. Okay, in ETABS we have to provide these values, but there is a correction, and that one is please select normal. okay, so if you select normal, in that case you will get the accurate result, otherwise you will get wrong result. okay, fine. Here windward value equal to 0.80 and leeward 0.42. okay, 0.42. there is no need of providing minus value because ETABS is considering this as a leeward coefficient. okay, here E1 equals 0.14, which we have calculated previously, and E2 equals to 0.06. now wind speed is 65.7. that means we have to multiply these with 2.24. 65.7 multiply 2.24, we get 65.7 2.24, we get 147.16. let's consider 148. now exposure type will be B, importance factor 1, kzt equals 1, gust factor we have to check from Excel. gust factor here, okay, for rigid structure the value of gust factor is always 0.85. kzt equals 0.85. okay, here we have to select story 1 to story 8 include parapet of 1 meter or 1 meter, that means 3 feet something, then okay. Now go to wind Y, modify lateral load. Here we have to take this as parallel. Okay, we have to take this value as parallel so that leeward value is 0.50. Okay, it's okay. Then here modify, the direction is 90 degree. Okay, then this one is 0.14 and this one is 0.06. Here 0.06. Now here use 148 exposure, B importance factor 1.85, 0.85. Select story 1 to story 8, include parapet of 1 meter. Okay, so we have completed defining wing load in ETABS. Now just save the structure. Now what is the next step? Next step is we have to define and apply all types of load in our structure. So what are other loads? There was some other types of load like wall load, partition wall load, floor finish. Okay, which one is wall load? The wall which are resting on beam will be considered as wall load. Walls which are directly resting on slab will be considered as partition wall load. In this tutorial we are going to apply partition wall load as area load. That means we will apply this load by the unit of kilonewton per meter square. Okay, you can also apply this load as a linear load, but in that case you have to model some non-beam in your structure. In my channel there have tutorials that how you can draw non-beam, so we will not waste time. In this tutorial we will consider partition wall load as area load. So place OK. Now go to story 1, apply. Okay, we need another window here. Okay, fine, just ignore this one. Select object type beams. So we have selected all the beams. In beam we will apply wall load. Okay, basically the equation for calculating wall load equal to unit weight of brick multiplied by height multiplied by thickness. Okay, if you calculate this for 5-inch wall, you will get a value of almost 7 kilonewton per meter, but there may have some opening in all wall. In that case we will consider here 5 kilonewton per meter wall load. Okay, but if we go to story 6, that means which is roof, at roof load there will be no wall load. There will be some parapet wall which we will assign manually. So but here we have to apply wall load. Okay, here we also have to apply wall load. Okay, because this is the staircase. Now for top floor, there we have already modeled shear wall or RCC wall, so we don't need to apply loads here. Okay, fine. Now apply wall loads to the remaining beam. Go to metric SI unit, assign frame load distributed, select wall load from here and apply 5 kilonewton per meter. You can assign this load part by part by calculating manually, but here I am applying same values for whole structure. Close. Now select all the floats, but before that I need to select this beam. Here we can assign some wall load. Okay, here assign frame loads distributed, apply 2.5 for this. Okay, save this one, select object type floats, select. Okay, but now we will assign partition wall load, but for roof there is no necessity of applying wall load. So we are unchecking this. Now for this all shell we are applying a partition wall load of 2.5 kilonewton per meter square. Basically the equation for partition wall load equals unit weight of brick multiplied by volume of brick divided by area of the room. If we calculate separately for each shell, you can do this, but here I am applying uniform value of 2.5. Okay, but before that I need to uncheck this one and uncheck this one. Finally go here and assign this time shell load, and this will be uniform, this will be partition wall load, and this will be 2.5. Basically if you calculate this value manually, you will definitely get less value than 2.5. okay, but according to BNBC there is a provision that you have to provide at least 2.37 kilonewton per meter square, but we are providing here 2.5 kilonewton per meter square. Okay, that means minimum you have to apply 2.37 kilonewton per meter square, but we are taking here 2.5 apply. Okay, now there is live load and there is floor finish. Okay, let's go to define, select object type floats, select close. Okay, now we will assign live load according to BNBC for structures where two families are living or two unit structure. There is a provision that you have to apply live load of 1.5 kilo. You have to apply live load of 2 kilonewton per meter square. Okay, but for roof we will consider that client will do some gardening here, so we will not select this roof. Okay, we will take this value. Okay, but we will assign to okay, now for remaining structure we will uncheck this one, and for remaining structure we will assign a live load of 2 kilonewton per meter square. So go to shell load and uniform From here you will have to select live load and you have to select 2 kilonewton per meter square. Now for roof we will apply a live load of 4.8 kilonewton per meter square. Also select these things. Okay, assign shell load uniform 4.80, apply. Okay, now again select all the slab, select object type, floors, select close. Now we have to apply floor finish. The value of floor finish is equals 1.20 kilonewton per meter square. We can apply some more values for roof slab. Okay, so uncheck these things. Okay, for a staircase also we will, okay, we can check this. We have to uncheck. We can do this for one. Okay, fine. Let's select this one and apply. Assign shell load uniform floor finish. This will be 1.20. That means 25 psi. Basically for roof we will apply 1.50. We have applied 1.2 here, so don't need, apply 1.5. Assign frame load shell load uniform 1.5 here, apply. Okay, we have completed assigning loads in our structure, but we have to add water pressure. We have to add water pressure here. So go to this Excel, non-uniform shell. Here height equals 7 feet. That means 7 divided by 3.28 equals 7 divided by 3.28 equals 2.13. Okay, length was 9 feet 33 and width was length was draw dimension line, length was 4.11 2.84 4.11 4.11 2.84. Okay, after, so distributed water load 21.30. So select the bottom slab, that means this slab, and assign shell load uniform, assign these as live load, okay, and this one will be 21.3. replace the other values. Okay, so let's check have we provided all the values or not. So from here we can go to display load assign. Okay, initially check frame loads. Okay, in frame which load we have provided? We have provided wall load. So let's go for live load. There is no option for viewing live load, but there is option for viewing wall load. So click apply. We can see that for all structures we have applied live load. Okay, wall load. Okay, then we need to go partition wall load. Okay, there is no option. Floor finish, then earthquake X not necessary, then go to display, load assign, shell load. Here you can see live load we have assigned, live load. We have applied live load to all the floats. Then we have applied partition wall load. Okay, there is no partition wall load for roof. Okay, otherwise there is partition wall load in remaining floors. Okay, then go to floor finish, apply. Okay, fine, perfectly done. Then it's okay. Now I need to check something, that is this is landing beam. Okay, in landing beam which load we have applied, need to check. Okay, 5 kilonewton per meter square. It's okay. Now what we have to do, define mass source, define mass source. Okay, so go to define, go to mass source, modify this one, uncheck these two and check this one, add dead load, wall load, partition wall load, floor finish. For these 4, multiplier will be 1. That means this total load will participate in seismic response, but for live load we will take here 0.50 according to BNBC and SEI, which suggests us that if there is any live load more than 3 kilonewton per square, 50% of live load will be participating in seismic response. So place OK. Yes, let me check this one again. Here I have to select live load and OK. Now modify this value, modify this value to 0.5, modify. Okay, let me check it again. Okay, this is okay, press OK. So that's all for today. We will do the rest of things in our next tutorial. Thank you.